All right, so in this video, what we're going to look at is solving two-step equations. So that just means we're kind of kicking things up a notch. So that's why it says, what if I make things more complicated? So I wanted to create steps for you just like I did for one-step equations. Step one is going to be to combine like terms. And this is something we want to make sure that we review too. So I'm going to put a little note to the side. Like terms, those are things that have the same variable and the same exponent. So 2 plus 3x, those are not like terms because 2 does not have a variable, but 3x does. So step 1 does not apply to number 1 here. But if it did, that's the very first thing we want to do is to combine any like terms. All right, so we're going to move on to step 2. Step 2 says to get rid of the constant first. Remember, a constant is a number. It's just a number by itself. So no variable on a constant. Okay, so that means we need to get rid of the 2. That's our constant. So it's a positive 2. To get rid of positive 2, I'm just going to subtract 2. So remember, the inverse operations tell me if it's addition or if it's positive, you need to subtract. So I'm going to subtract 2, and I have to do it to both sides. So then that goes away, and I'm left with 3x equals 60. All right, then I have to get rid of the coefficient. Well, remember, a coefficient, and this is just vocab review, is the number next to the variable. Okay, so in this case, that is the 3. And it looks like that 3 is being multiplied by x. So I need to undo that multiplication by dividing. So that's where my inverse operation is coming into play. So I'm going to divide by 3 on both sides. Okay, and I'm going to bring it up here because I don't have room. Okay, 3 divided by 3, we know that cancels out because that's the whole reason we divided by 3. Then I'm left with x equals, and 60 divided by 3 is 20. So that is my final answer. All right, so we're going to move on to numbers 2 and 3. Those are the last two I'm going to do for this specific video. When we look at number 2, it looks a lot more complicated already just by glancing at it. And the reason is because we have some of those like terms. So I'm going to start over with step 1. It says combine like terms if there are any. Well, I have a 5x and a 7x. Those are the two things I have that have variables. So 5x and 7x are going to be like terms. So we have 5x and we have 7x. 5x plus 7x, that's going to combine to give me 12x. And then I can see that I have negative 2 and I have positive 14. Those two things are both constants, which means I'm allowed to combine them, right? They don't have a variable and they don't have an exponent, so I can just combine them. Negative 2 plus 14 is positive 12. So again, if you're not comfortable with that, you can just put it in your calculator. So then I'm going to get plus 12, and over here I still have equals 180. All right, so I have 12x plus 12 equals 180. All I did was I combined my like terms. So I'm kind of back at square one now. Step 2 says get rid of the constant first. Well, which one of these is the constant? So I have 12x and I have positive 12. Remember, the constant is the number by itself, so that's going to be this guy right here, that positive 12. I need to use my inverse operation to get rid of that positive 12. So I'm going to subtract 12 from both sides because it looks like I was adding originally. Okay, so I'm just going to draw an arrow since I don't have room underneath. And you guys can do the same thing when you're doing your homework that's based on these notes. So 12 minus 12, that cancels. So I'm left with 12x on the left side. And on the right side, I have 180 minus 12. So again, you can put that in your calculator. I do 180 minus 12, which is 168. And now I've gotten it down to a one-step equation. I know that 12 is being multiplied by x, so I need to use my inverse of multiplication, which is division, because I want to get x by itself. So I'm going to divide by 12 on both sides. And that's going to cancel because 12 divided by 12 is just 1. And then I'm left with x equals, and then I do 168 divided by 12, which is 14. Okay, so the reason that one felt so much longer is because we had to do the extra step of combining like terms first. All right, so other than that, it's just a two-step equation. We subtracted 12 first, and then we divided by 12. And again, that happens on both sides of the equation. So let's look at one more. We're gonna look at number 3, and I'm gonna zoom in on this one a little bit more so that way I have more room to write. So number 3, we just have 90 on the left side. Nothing can happen with that. That's just gonna stay 90. But on the right side, I have some things I can combine. So I'm gonna look, I have 2 terms that have an x in them. So that's 13x and negative 11x. Okay, I can combine those 2 things because they have the same variable and the same exponent. So I know 13x minus 11x is just 2x. So that's what those combine to give me. Okay, so I just took these 2 things and transformed them into the term 2x. Then my other like terms are just the numbers. Okay, right, so positive 9 and positive 6. So 9 plus 6 is just 15. And then nothing happened over here with the 90. So now I have 90 equals 2x plus 15. Step 2 said to get rid of the constant. The constant over here would be the 15 because it's the number without a variable and it's a positive 15. So that tells me I have to subtract it if I want to get rid of it. Right? So then when I do 90 minus 15, I should get 75. So then I have 75 equals, that 15 minus 15, well, that just cancels, right? That goes away. So I have 75 equals 2x. All right, last step. I need to get x by itself. I don't want that 2 there. So I know that what I have to do is look at, well, what's happening between the 2 and the x? They're being multiplied. That tells me I have to divide both sides by 2 to get rid of that 2 on the front of the x. That's my coefficient. So if I divide both sides by 2, that's going to give me my final answer. So x equals, and then 75 over 2, it's not going to be a whole number, but it's close. So x equals 37.5. And if you left it as 75 over 2, that's all right also. So you would not get counted off for leaving it in fraction form. All right, so that is our video on two-step equations and combining like terms. In the next video, we're going to look at what happens when you have variables on both sides of the equation. So when I have an x on both sides.